The last of the communication buses to look at is Ethernet. In the Crestron system, there are many common Ethernet devices. These include Crestron devices such as digital media switches or touch panels, and many third-party devices. Ethernet has many benefits. Since Ethernet is a standard, Ethernet devices share common wiring and termination standards, making cabling and termination easier. Ethernet is a high-speed and high-bandwidth communication, allowing for responsive control of devices. There are, of course, large numbers of devices supported. Many Crestron devices support Ethernet along with thousands of other manufacturers. Any manufacturer can use their communication method for their protocol, allowing the devices to be controlled by Ethernet easily. Many devices support PoE, or Power over Ethernet. This allows the device to receive data and power on the same cable. Ethernet uses easily sourced distribution devices such as routers and switches. In many cases, the configuration details for a device will not be an issue to you. However, it's useful to know what these details actually mean. Let us have a look at a glossary of some IP terms. In a similar way to CrestNet, an Ethernet network will have many different devices connected. In order to communicate, each device needs a unique ID on the network. Compared to CrestNet, which can cater to only 252 devices, an Ethernet network can have a huge amount of devices attached. Think of the Internet, where there are millions of devices talking to each other. The ID then needs to be a much bigger number. Each device on the network is given a unique IP address or Internet Protocol address on the Ethernet network. An IP address can be either IPv4 or IPv6. Commonly, we use IPv4 addressing where 4 decimal numbers separated by dots represent the address. For example, 192.168.0.100 IP addresses can be fixed on the device directly, which is called a static address, or assigned automatically by device in the network. This automatic addressing is called DHCP, which stands for Dynamic Host Configuration Protocol, and requires a DHCP server. Static addressing requires more configuration of the device. This can be useful if you want a device such as a control processor to always have the same IP address. Another piece of information you may need is a subnet mask. An IP address has 2 parts. The first part is the network address, which should be the same on every device in that section of the network. The second part is the individual host address, which is unique to that device. It's similar to a postal address, which is also made up of several components. Like a zip code or street address identifies a group of buildings, which are then further identified by the building number, a subnet mask also specifies how many devices can be placed on that network. Let's have a look at a couple of examples. In this example, the subnet mask we have been given is 255.255.255.0. This indicates that the first 3 parts of the address are for the network and cannot be changed. The last part can be changed, giving us a range of 0 to 255, or 256 numbers. This subnet mask allows for 254 unique devices on the network. We cannot use 0 because this is a subnet ID. We cannot use 255 as this is the broadcast address. For example, this could give us a range between 192.168.0.1 up to 192.168.0.254. Another common subnet mask is 255.255.0.0. The first 2 parts of the address are for the network and cannot be changed. The following 2 parts for the unique device ID. This gives us many more devices, 65,534. And as before, the very first and very last available addresses are used for the subnet ID and the broadcast. This would give us a range of 192.168.0.1 to 192.168.255.254. Of course, this range is given as an example and may well be different. Another consideration is the Ethernet port that will be used. Once information is delivered to a device by its IP address, it's necessary to give the information to the right application. In the postal address comparison used earlier, the Ethernet port could be the name of the addressee. Once the letter arrives at the house, you must ensure the right person reads it. Commonly used ports include port 80, which is for HTTP Hypertext Transfer Protocol or Internet traffic, and port 21, which is a common file transfer protocol. Common Crestron ports include 41795, which is a Crestron terminal protocol used for file transfer using Toolbox, as we will see shortly, and 41794, the Crestron Internet protocol. This is used for communication between devices in a system. With an IP address and a subnet mask, devices in a network can now communicate with each other. If devices on that network need to communicate with another device on a different network, it needs to be sent via a device that knows how to communicate with other networks. This device is specified as the default gateway. The default gateway routes Ethernet traffic across different networks. It's referred to as a router. The default gateway is often the first address on the network. For example, 192.168.0.1. If the device does not need to communicate with something on a different network, the default gateway is not required. A host name is a human-friendly name for a device on a network. Let's use the internet as an example. If I wanted to go to the Crestron website, I can type www.crestron.com rather than an IP address. It's like a nickname, while the IP address is the real name. If a host name is used, then a transmitting device will need to look up the real address or the IP address of that destination. Domain Name System Server, or DNS server, performs the translation between the host name and the IP address. This information must be added to a device if host names are to be used. An Ethernet device also has another type of address, the MAC address, or Media Access Control address. Sometimes also called physical address, the MAC address is the hardware address of a device as opposed to the software setup of an IP address or host name. The device's manufacturer normally assigns the MAC address. A MAC address is unique to the device, regardless of the Ethernet network it's on. There's a possible 281 trillion MAC addresses. When network switches and routers use the MAC address internally, we usually do not need to worry about them. Many devices can also receive power over the network connection using the Power over Ethernet standard. When using PoE, it's important to ensure that the PoE power supply has enough available power for all the devices connected to it. Devices will list their power requirements by stating their class, as outlined here. Some power supplies will have multiple ports, all listed at Class 3. However, the device is not capable of supplying Class 3 simultaneously to all of the ports. This information will be in the specifications, and it's worth checking. Ethernet with PoE is now widely used in place of CrestNet for Crestron devices, as this allows a single wire connection to all of the devices. If multiple PoE devices are to be used, the best option may be to use a switch with PoE enabled on the output. If it's for a single device, then a PoE injector can be placed in line. If Crestron devices are to communicate with each other on an Ethernet network, it's necessary to set up an IP table on those devices. An IP table has two parts of information. The first part is the IP address of the device on that network. The second part of the address is very similar to CrestNet. There are 252 available IP IDs. The IP ID set on the device must match the IP ID of the device set by the programmer on the program. The process of connecting to the device and setting the IP ID using the Toolbox software is covered in another video in this series.